Arithmetic in NumPy is very convenient, as we discussed before, because it's much easier to do element-wise operations in NumPy than it is to do them with loops in Python. We've already seen this in the course above, but let's create a new array, array 4, and it's going to be a 2 by 3 array. And what do you think is going to happen if we subtract array 4 from array 4? Let's see. Well, we get 1 minus 1, which is 0, and 4 minus 4, which is 0. And similarly, we end up with a complete empty array. Well, what do you figure is going to happen if we add array 4 to array 4? Let's run it and see. We get 1 plus 1, which is 2. We get 5 plus 5, which is 10. And similarly, it does a value for value operation, an element-wise operation throughout the entire array. Now what we've done here is we've created a new array called array 5, and we've saved the value of array 4 plus array 4 in the new array, array 5. And so what do you think the value of array 4 times array 5 is going to be? Let's run that and see. Here we have array 1, which is 1, times array 5, which is 2. 1 times 2 is 2. And here we have 4 times 8, which is 32. And similarly, element by element throughout both arrays. One thing we want to mention here is that this is not doing matrix multiplication, is it? Matrix multiplication as far as getting either the dot product or the cross product of a matrix. This is simply a value to value element-wise operations. So what do you think we're going to get if we run array 5 divided by array 4? Here's the value of array 5, 2, divided by 1 should be 2. And 10 divided by 5 should be 2. So we should get an array of 2's here. And that's indeed what we get. Well, just as we can do arithmetic operations in NumPy, we can also do comparative operations. What happens if we ask the question, is array 5 greater than array 4? And again, here's array 5, and here's array 4. Indeed, array 5 looks greater than array 4, so we should get a Boolean true for this comparison. Now, what if we ask the question, is array 4 greater than array 5? Well, these cannot both be true, can they? So we should get a false Boolean result. Now, part 2 of this course is about indexing and slicing. And we're going to see that selecting subsets in NumPy data can be quite similar to selecting data subsets in Python. Let's create this NP array here. It's a one-dimensional array with 10 elements. These are indexed the same way that a Python list would be indexed, where this is index 0, index 1, index 2, index 3, and index 4. So we can access these values using indexing the same way that we did in Python. That should return a 4 to us. What if we begin this NumPy array at 3 instead of at 1, and then we run this again? What value do you think we're going to get? You think we're going to get a 7? Yeah, because this became a 0 index, 1, 2, 3, and 7 became the 4th index. Let's return this to what it was before and talk about getting a slice out of here now. Just as these slice operations were similar to the range operation in Python, so are they similar to the arrange operation in NumPy. So what are the values that we're going to return from this slice? Well, we're going to start at 3 inclusive, and we're going to end at 7 exclusive. So let's see what we get. We start at 3 inclusive, and we end at 7 exclusive.